Hello students, let us continue the session on surface area and volume. We have discussed the main concepts and the formulas used for calculating surface area and the volume. In today's session, we shall take up exercise 13.1 and solve the questions which are related to surface area. First question is related to cube. Unless stated otherwise, take pi equal to 22 upon 7. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. Here, there are two cubes, and those two cubes are having volume equal to 64 centimeter cube. When the volume of the cube is 64 centimeter cube, I can find the volume because the volume is side cube. So the side will become cube root of 64, which is 4 into 4 into 4. So it is cube root of 4 cube. So we get 4 centimeter as each side of the cube. When the side is 4 centimeter, we will have the height equal to 8 centimeter and the breadth will be 4 centimeter. So the surface area of the resulting cuboid will be two times of LB plus BH plus LH. Observe this figure. The length is 4 centimeter, breadth is also 4 centimeter, height is 8 centimeter. We'll substitute these values in the given formula. We get 2 times of 4 multiplied to 4 plus 4 multiplied to 8 plus 4 multiplied to 8. We get it as 2 times of 16 plus 32 centimeter square. The sum of 32 plus 32 is 64, added to 16 is 80, multiplied to 2 is 160 centimeter square. So the surface area of the resulting cuboid is 160 centimeter square. Second question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. The diameter of the hemisphere is 14 centimeter. The total height of the vessel is 13 centimeter. Find the inner surface area of the vessel. Here, 13 centimeter is the total height of the vessel. You have given that diameter is 14, so the radius will be 7. From here to here, the radius will be 7. So 7 should be subtracted from 13 to get the height of the cylinder, which is 6 centimeter. Here they have mentioned that radius of cylinder as 7 centimeter. Therefore, the height of the cylinder is 13 minus 7, which is equal to 6 centimeter. And radius of hemisphere is 7 centimeter. We need to find the inner surface area of the vessel. So inner surface area of the vessel will be equal to the curved surface area of cylinder plus the curved surface area of hemisphere. The curved surface of the cylinder is 2 pi RH plus, for hemisphere, the curved surface area is 2 pi R square. So we get 2 times 22 upon 7 multiplied to 7 into 6 plus 2 times 22 upon 7 multiplied to 7 into 7. Here one of the 7 get cancelled. We'll be getting 44 times 6 plus 44 times 7. Here 44 taken common, 6 plus 7 will be equal to 44 times of 13, which is 572 centimeter square. So the inner surface area of the vessel is 572 centimeter square. Question number 3. A tie is in the shape of a cone of radius 3.5 centimeter mounted on a hemisphere of radius, which is same radius, and the total height of the tie is 15.5 centimeter. Find the total surface area of the tie. Here they have given the height of the tie as 15.5 centimeter and the radius is 3.5 centimeter. So the height of the cone will become equal to 12 centimeter. So radius of cone is mentioned. Radius of cone equal to 3.5 centimeter. Height of cone is 15.5 minus 3.5, which is equal to 12 centimeter. And the radius of hemisphere is 3.5 centimeter. To find the curved surface area of cone added to curved surface area of hemisphere, we need the slant height. So the slant height can be found. This will be L, which is equal to root of R square plus H square. Here it is root of 3.5 square plus 12 square. 3.5 square is 12.25 plus 144. This is under root. This will be equal to root of 156.25. You can calculate. It becomes 12.5 centimeter. So the total surface area of tie will be equal to curved surface area of hemisphere plus curved surface area of cone. The curved surface of hemisphere is 2 pi r square plus the curved surface area of cone is pi rl. Since radii they are same, I can take pi r as common. We get 2r plus l. This will be equal to 22 upon 7 into 3.5 into 2r is 7 plus L is 12.5. We get 7 plus 12.5 as 19.5. 19.5. So 7 1 time, 7 0.5 times is 3.5. So 11 is multiplied to 19.5. So 11 multiplied to 19.5 is 214.5 centimeter square. This will be the total surface area of the tie. Question number 4. This is one of the very important question. It is asked in examination. A cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere can have? Find the surface area of the solid. Here, a cubical block is surmounted by a hemisphere. They have mentioned that the side of the cubical block has 7 centimeter, hence the diameter of the hemisphere will be 7 centimeter. They have asked what is the greatest diameter of hemisphere. Here, the greatest diameter of hemisphere will be equal to side of a cubical block, and they have given it as 7 centimeters. So that could be the maximum diameter. So we can find out the radius of hemisphere. So the radius of hemisphere will be equal to 7 upon 2, which is 3.5 centimeter. Now the question is to find the total surface area of solid. This total surface area will equal to the surface area of cubical block plus the curved surface area of hemisphere minus area of base of hemisphere. You must be getting doubt, why did I subtract this area of the base from this area? So surface area of cubicle plus curved surface area of hemisphere. Why did I subtract? It is because this top of cube has got a hemisphere on that. So this particular area is embedded that has to be removed. If you add these two areas, that becomes extra that has to be removed. Therefore, we have 6a square plus 2 pi r square minus 2 pi r square. Sorry. This is minus pi r square, not 2 pi r square, pi r square. Pi r square basically because it's the area of circle. The base of the hemisphere is a circle. So it is nothing but 6a square plus pi r square. We'll be getting 6 times of 7 square plus 22 upon 7 into radius is 7 by 2. So 7 get cancelled. 2 11 times. We'll be getting 294 plus 38.5, which is 332.5 centimeter square. This is the area of the solid. Next question. A hemispherical depression is cut out from one face of a cubical wooden block such that diameter L of the hemisphere is equal to edge of the cube. Determine the surface area of the remaining solid. Here, hemispherical depression is cut off from one face of a wooden block. You can see here, this is hemispherical depression made in the cubical wooden block. Here, as we have discussed in the previous question, the diameter of hemisphere will be equal to side of the cubical block. So diameter of hemisphere is equal to side of cube. This is equal to L. Therefore, the radius of hemisphere will be, this is not correct, this is hemisphere. Made a mistake while writing, this is hemisphere. Radius of hemisphere will be equal to L upon 2. Therefore, the surface area of the remaining solid will be equal to the total surface area of cubical block plus the curved surface area of hemisphere minus the area of base of hemisphere. This will be equal to 6 times L square plus 2 pi r square minus pi r square. Here minus pi r square is done so that this particular phase only this part, remaining part is considered. I am highlighting that remaining part. So from this phase pi r square is removed off. Therefore, this will be equal to 6L square plus pi r square. So 6L square plus pi times L by 2 whole square. This will be equal to 6L square plus pi L square by 4. We can take L square as common, so L square times of 6 plus pi by 4 will be the required surface area of the remaining solid. Question number 6. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends as shown in the figure here. The length of the entire capsule is 14 mm. Diameter of the capsule is 5 mm. Find the surface area. For the better understanding, I have taken the figure like this. Here 14 mm is the total length. So 14 minus the diameter gives the length of this particular cylindrical part, which will be 9 mm, and the radius will be 2.5 mm. It's 5 by 2. So from ear to ear it is 5 by 2. From here to ear also it is 5 by 2. The diameter is 5, so the radius is 5 by 2. So let me mention that here the radius of cylindrical part is 5 by 2, which is 2.5 mm. Length of the cylindrical part is, from 14 you need to subtract 2.5 plus 2.5, because from this side to this side it is 2.5, from here to here it is 2.5, that has to be removed. We'll be getting 9 mm, and the radius of hemisphere is 2.5 centimeter. Now the surface area of capsule will be equal to the curved surface area of cylindrical part added to twice the curved surface area of hemispherical part. isn't it? So this will be equal to 2 pi r h plus 2 times of 2 pi r square. So we get it as 2 pi rh plus 4 pi r square. We can take 2 pi r as common. I'll be getting h plus twice of r. So this can be simplified. 2 times of 22 by 7 multiplied to the radius is 5 by 2 plus into h is 9 plus 2 times of radius is 5. 5 plus 9 is 14. It becomes 2 times 2 and 2 will get cancelled. We will be getting 220 millimeter square. This will be the surface area of the capsule. Question 7. A tent is in the shape of cylinder surmounted by a conical top. If the height of the diameter of the cylinder is 2.1 meter and height and diameter, height is 2.1 meter and 4 meter is the diameter, and the slant height of the conical top is 2.8 meter, find the area of the canvas used for making the tent, that is the surface area. Also find the cost of the canvas for the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be considered because it will not be covered. So we should not consider the base, neither the upper base nor the lower base. So this will be the tent, this a cylindrical part on that a conical structure. Here the height of the cylinder is 2.1, the diameter is 4, hence the radius will become 2 meter. Slant height is given. So what are the things we need? We need the height of the cylinder, which is given. Height of cylindrical part is 2.1 meter. Diameter of cylindrical part is given as 4 meter. This implies the radius is 2 meter and the height of the cone, height of conical part. Let me mention this as a slant height of the conical part. This will be equal to 2.8 meter. When we are finding the curved surface area of the conical part, we require only the slant height, not the height of the cone. So slant height is already given. The height of the cylindrical part is also given. So the area of canvas will be equal to the curved surface area of conical part plus the curved surface area of cylindrical part. For the conical part, it is pi rl plus 2 pi rh. We can take pi r as common. We get L plus 2 times h. So 22 upon 7 multiplied to the radius is 2 times of the slant height is 2.8 plus 2 times of the height is 2.1. 2 times of 2.1 is 4.2 added to 2.8. We'll get it as 7. The 7 and 7 will get cancelled. We'll be getting 44 meter square. Therefore, the cost will be equal to rupees 500 per meter square multiplied to 44 meter square. Meter square get cancelled. We'll get rupees 22,000. So rupees 22,000 is the total cost and 44 meter square is the total area. Question number 8. From a solid cylinder of height 2.4 centimeter and diameter 1.4 centimeter, a conical cavity of the same height and the same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. This will be the structure. It looks like a cylinder. In that, a conical part is hollowed out. The height of the cylinder is given as 2.4 centimeter and the diameter is 1.4 centimeter. Here, the height of the conical part is same as the height of the cylinder. And they are given as 2.4 centimeter. Diameter is given as 1.4 meter. This implies that the radius is 0.7 meter. To find the curved surface area, we actually require the slant height. So first let's find out the slant height. So the slant height of cylindrical part will be equal to L. This is root of r square plus h square. Let's substitute. R square is 0.7 whole square plus 2.4 whole square. 0.7 whole square is 0.49 plus 2.4 multiplied with 2.4 is 5.76. When they are added up, we get it as 6.25. This is a perfect square. It is 2.5 centimeter. So the total surface area of solid, remaining solid, will be equal to the curved surface area of cylinder plus curved surface area of conical part. Is that enough? No, because this side I need to consider the base. So plus area of base of cylinder. Let me write the formula here. It's pi RH. It's 2 pi RH curved surface area of cylinder plus for the cone it is pi RL plus the area of the base is pi R square. This has to be substituted. Upon substituting, we'll be getting 2 times of 22 upon 7 multiplied to 0.7 into 2.4 plus 22 upon 7 into 2.5 plus 22 upon 7 into 0.7 into 0.7. For simplification, I can simplify without taking common. 7 0.1 time. Here I have missed out something. Here it is 0.7 is missed out. This will become 0.1 time. Here also it is 0.1 time. We will be getting 4.4 multiplied to 2.4 plus 2.2 multiplied to 2.5 plus 2.2 multiplied to 0.7. Let's multiply. This 10.56 plus 5.5 plus 1.56. On addition, we get 17.6 centimeters square. Question number 9. A wooden article was made by scooping out hemisphere from each end of a solid cylinder as shown in the figure 13.11. If the height of the cylinder is 10 centimeter and its base radius is 3.5 centimeter, find the total surface area of article. Here it's very clear that the radius of cylinder and the radius of hemisphere would remain same, and they have given it as radius of cylindrical part and hemispherical part. Hemispherical. They have given it as 3.5 centimeter. The height of the cylinder is given. The height of the cylinder is 10 centimeter. So the total surface area of cylindrical part the total surface area of article will be equal to the curved surface area of cylinder plus the curved surface area of two of the hemispheres. So it is 2 pi RH plus 2 times of 2 pi R square. Let's substitute. Before that, I'll take 2 pi as common. I'll get RH plus R also can be taken common. Let it be to R square. Substitute. We get 2 times of 22 upon 7 multiplied to the radius is 7 by 2 times of the height 10 plus 2 times of 7 by 2 into 7 by 2. Simplify, we'll get 374 centimeter square. You can cross check this. It is 374 centimeter square. So we have completed the first exercise of this chapter. That's all for today's session. Thank you.